In the last video, I was having a bit of a whinge about the way that certain terms in software development are used to cover a huge variety of different concepts. And specifically, last time I was talking about the use of the word model. Now this week, we're going to be talking about configuration in Entity Framework Core. And you might be thinking, well, didn't we cover that a little while ago? Well, we did, but that was looking at configuration in terms of decisions like what database are we actually going to be using? Is it going to be SQL Server or Oracle or whatever? And also in terms of the connection string to find the specific location of that database. The configuration we're talking about this time is the details of actually how our entity classes map onto tables and how our properties map onto columns and that sort of thing. And in fact, Entity Framework Core gives us two very different ways of achieving essentially the same thing with this. In the next video, we're going to look at the idea of the Fluent API, but this time we're going to be looking at doing it all through attributes, which is probably the simpler way of doing it, so that's what we're going to start out with. And if we take a look at the application we've been using throughout these, we can see that we've still got the idea of our book with various properties, and a book has an author, and then an author has its own properties and has a collection of books. And for the purposes of what we're doing this week, all we're going to do is in our console application on that database through the books context, we're just going to do an ensure deleted and ensure created every time. And what that means is we'll just get a brand new database every time. So when I make the changes using these attributes, we can see what's happening. I could have done this just as well through Code First Migration, typing add migration into the package manager console, but it's just a bit quicker this way to show what's going on. So let's begin actually with no attributes at all, nothing beyond the basics, and just see the database that's created. So if I just run that, and that's now generated the database. And if we look in SQL Server Management Studio, just refresh our databases there. There we can see we've got books library with attributes. That's what I called it. And if we look in there, we've got a couple of tables. We've got our authors and our books. And if we just look at the design for them, so there's our authors, we can see a number of things it's done pretty much automatically. In both cases, it has named the tables authors and books. And where it gets that from is what we did in our books context. The fact that we've got these collection properties, DB sets called authors and books, whatever you put there is what is going to be used for the table name. The other thing we can see is the properties are pretty much straightforward. So they become column names, and the types are fairly obvious. So when we have a string, that becomes an nvarchar max, so maximum length using Unicode, that's what the N stands for, and then the date of birth is a particular type, date, time too. One other thing it's done is it's spotted that our ID is the primary key. So we didn't do anything special with that, just the fact we'd gone for the name ID has worked there. And if we then look at our books, same thing goes in terms of the fact it's been called books based on what was in the DB context. Similar sort of things. The other thing it's done here though is in generating the foreign key that joins us to the authors, it's simply taken the entity name author and put ID on the end of that. So that wasn't anything specific in our code, it just worked that out. Again, because if we look at the book, a book has got an author, so that's the name of the property, so it plonks ID on the end of that to give us author ID. Now, one of the things we haven't mentioned before is actually, if we go to our books context, or whatever our DB context is, you don't, strictly speaking, have to list all of your entities as DB sets within the DB context. We could just list books, and authors would still be part of the database because there is a navigation path. If we've got a book has an author, therefore the system knows it should be included in the database. Now, whether in practice you actually do this, I'm not so sure. Certainly in the case of authors and books, I think I'd want to be able to directly access authors as well as access them through books. But you can imagine other situations. Maybe you have an invoice which has a collection of invoice items. You might decide you don't need to access the invoice items directly. It's not a huge cost, but it's something that's available. But if we do that, we'll see now, if we again rerun the program, and remember what it's doing is deleting and recreating the database, so it will give us the changes. And if we now refresh that, you can see that what it's now done is it has simply taken as the table name the class name. What it has not done, as it would have done in EF6, the earlier version, it has not pluralized that. So the class name is author and the table name is author. And that's a bit unconventional because normally classes definitely singular, tables tend to be plural. You don't have to follow that convention, but if you do, it's a bit odd that we've got books plural, author singular. So obviously we could just go back and put it in the DB context, but one other thing we can do is introduce our first attribute. So if you ever want the name of the table to be different from either the name of the class or the name of the collection in the DB context, then you can just pop on an attribute called table, get that from system.componentmodels.dataannotations.schema, and then you can specify in there the name that you want the table to actually be. So here we want it to be authors. We could also do that on our book, for example, and if we wanted the name to be something completely different, we could do that as well. So I'm not going to go for books, I'm going to go for something completely different. Let's make that volumes. And so now if we run that, it'll regenerate again. And so now we can see when we do the refresh and look at our tables that it's put the authors and the volumes. So those are the names of the tables mapping onto whatever we have as the class names, author and book in this case. Now, in general terms, I would really recommend avoiding that sort of thing. Having a radically different name, book as the entity, volumes as the table, is just going to cause confusion. So wherever possible, keep them identical apart from the pluralization, author goes to authors, book goes to books. But there may be some situations, particularly if you've got a legacy database that you've got to apply to existing classes or something like that, where you do need a radical difference like that. So that's the sort of thing we can do. But in general, whatever we're trying to do, it's best to actually express what we want in C# code, not to use attributes at all. For example, if we look at our volumes, as it's now called, we can see that the title is nullable, so there's the tick in the allow nulls column, and the year of publication is not nullable. And the reason that has happened is simply because if we look at the code, we can see title is a string, which is a reference type in C#, therefore can be null, whereas year of publication is a value type and therefore cannot. And if we wanted to change that, then it's best to do it just in C# code. So if I simply make year of publication a nullable int in C# and then run this all again, and then just take another look at that. Now we can see that year of publication allows null, so it's just worked that out for us. When it comes to reference types, it might be a little bit trickier. If we're using C# 8, well then we've got the nullable references as well. So I could simply go in here, and if I just do my hash nullable enable, so just enable the nullable references in C# 8 on there, and then if I change that to a question mark, then that now is nullable. Also, it applies on navigation. So you'll notice that our author, if we look over here, you can see our author is nullable. So what that is saying is that a book may or may not have an author. Whereas if we leave that as a non-nullable reference, in which case we've got to do a bit of a cheat there, put our null forgiving operator on there, and then run that. Now we can see that our title is nullable and our author ID is not nullable because we've said you've got to have an author. So we can control that allow nulls column in C# 8 for both reference types and value types just by making them nullable or otherwise. However, if for some reason we're not using C# 8 and we don't want to do it that way, there is another way of doing it as well. So let's just take that off and therefore take that off there. The other thing we can do is do it through an attribute. So as I said, wherever possible, do it in the language, but we have an attribute where on here I can say required. And so required simply means it cannot be null in the database. And you can do that on any one of your columns. We could do that on the author as well. And so running that, so at the moment title does allow nulls, but if we look at the new version, you can see it's not nullable because we specified that it was required. Now this actually leads us on to another interesting point. Remember last time I was talking about the difference between entities and models. So entity is what we're dealing with here that connect us to the database, and then models in MVC that connect from the controller to the view. And we said that sometimes in simple cases you actually use the same classes for both of those. Well, when you do that, the attributes that you put on, like required, may or may not apply in both circumstances. So if I just look at our book model that we still had available here, if I were to put the required attribute on there, and just get hold of the namespace, then on a model that means something slightly different. That means that if we had an edit view, for example, on our website, and if we configured it correctly, then the user would be required to type in a title. You wouldn't be allowed to leave that field as blank. You'd get an error if you did. So it's a similar concept, says you've got to have a title, but it is doing two different jobs. One is saying in terms of the view, the user has to provide a title, whereas over here, we're saying in terms of the database, the column in the database has to be not nullable. If, again, as we were discussing previously, you don't separate the idea of the entity and the model, you have just a single class to do both, then obviously that required term will do both jobs. And it turns out that there are certain of these attributes that only apply to entities. For example, table only makes sense in terms of the entity. Required actually applies for both. But then there are other things you may have come across in models, like for example we can have a display and then name equals and then maybe year of publication with spaces. All that is doing is specifying how this property should be labelled when it comes to the view. So that's an example of an attribute that only affects the view and wouldn't have any effect even if this were also an entity as well as a model. Getting back to our entity, let's have a look at some other things we can do. One thing we've got here that we already saw is that if we have a property of name ID, then that is automatically interpreted, we can see there, as a primary key. Two rules for that. Either you can just call it ID, which is what I personally like to call it, but you can also call it the class name followed by ID. So book ID works there. So two possibilities, either just ID or class name ID. There will be circumstances, however, where you want to do something completely different. For example, with a book, books have this thing called an ISBN, an International Standard Book Number, which you'd actually probably express as a string. And in that case, it's not going to be able to work out implicitly that that is the primary key. And in fact, you can see it's giving us an error when we run that, basically saying there is no primary key available. Again, we can do it with an attribute. So all we need to do is put key on there. And then when we run it, it knows that that is going to be the primary key. We can see it's got ISBN and it's made that the primary key. Another thing we sometimes might want to do is have a piece of data in the entity that never actually makes it to the database. So suppose our prices were being dynamically fed in from somewhere else, wherever it may be. We could just simply put on there, not mapped. So not mapped simply says it's in the class, but don't put it in the database. So again, when we run that, we can see it now doesn't have the price in there. It's still in the entity, but not in the table. Another one we saw had nice default behavior, remember, was the idea of the foreign key. So we saw that we just got author ID for the foreign key. And if we wanted to, actually, we could have, as well as having the reference, we could have put in a property here of type int that we call author ID. We'll discuss in a later video a lot of the pros and cons about how we do our collection. So for now, we'll just put that in there just to show you how it works in terms of these attributes. So if we do that, that will actually have no effect whatsoever on the generated database. So if we take a look, we'll see it still simply has the author ID, and the only difference is it will now have the value of that property specifically in the book entity rather than just having the reference. But what if we decided for some reason we wanted to follow a different convention? So suppose we wanted to have ID underscore author. That, for whatever reason, is our convention. So if we do that, we'll now see that it's had to create two of them. It's created author ID, and that is the one that has the foreign key constraint onto the author. So if we just take a look at the relationships here, we can see we've got the one that goes to author ID. So that's the one it's worked out as the relationship. And ID author, it just thinks is some value I want to store in there as an integer. So we've got to tell it that actually ID author is what I wanted to use as the foreign key column. Again, easy enough to do. Back here on the navigation property, so the reference to the author, I have to put an attribute of foreign key and then give it the name of the foreign key. So just as a string, ID underscore author, or in fact, as a safety mechanism, remember in C# we have name of, which is a better way to get hold of strings representing properties or whatever that we have. So that will just generate the string, but give us a slightly safer way of doing it. And so now when we run that, now you can see it's just got ID author. And now if we look again at the relationships, it's used ID author as the column that's going to have the foreign key on there. So that's just the way to do that. But again, I have to say, why bother? I would rather just go with the conventions and save these annotations, unless, typically for legacy reasons, you've already got your database set up this way, then just stick with the conventions. Last property to look at is actually one of the most flexible ones. This is how we start specifying things about columns. So, for example, we've got our property of year of publication. What if we just wanted that to produce a column called year? Well, simple enough. We can just say column year, and then when we run that, that's what we'll get in the database. So now we've just got a column called year. Again, just to emphasize, similar but different to what we have in the model. So in the model, we could do a similar sort of thing, changing year of publication to year space of space publication. But remember, that's all about what appears in the view, whereas that's about what appears in the database. So if you were doing this without the separation of entities and models, you might well have both the column and the display name on the same property so that it could map differently in both directions. Probably more important, and this is where I will use these attributes most, is not in terms of the column name, but in terms of the column type. Because as we've seen, there is a fairly standard set of rules as to how data types in C# map onto data types in the database. And we've seen, for example, that our title automatically just became the nvarchar max. The nvarchar 450, by the way, is because this is a primary key and it has to have a fixed size to work as a primary key. So that's why we've not got max in there. But if I wanted to change that, I can do it in a couple of different ways. One is on there, I could do column, and then we could have type name equals, and then as a string I can put in any database type, any SQL type. So if I say varchar 20 and then run that, we can see it's gone in there as a varchar 20. Now, I personally wouldn't really ever use varchar because varchar is just a ASCII character, whereas nvarchar is a Unicode character. And so you'd be losing the ability to have all sorts of non-standard characters in there. In terms of the number of characters, that can be reasonable in certain circumstances, save you a little bit of memory. But actually, in terms of the number of characters, there is an alternative way of doing it, because rather than having that column with a type name, we can simply put on there a max length of 20. So that now is going to be an nvarchar, it is going to be Unicode, but we can specify the number of characters allowed. So there, that's gone for nvarchar 20. And it's worth mentioning that this max length is another of the ones that actually does apply to a model. So if you put max length on a string in the model, then the view, if correctly configured, would ensure that the user wasn't allowed to type more than 20 characters. Another one we might be concerned with is our price, because price is a decimal and there are all sorts of different ways of representing decimals. So you can see here we've got what are known as the precision and the scale, and it defaults, and normally this is going to be okay, to a precision of 18 and a scale of 2. That's what fits in with a C#.NET decimal. But you can change it. Again, pretty straightforward. We can just do column, and then we will say type name equals, and then we could say something like decimal, and then if we went say 5,2, and we can see it's just taken that in there. So that's some control we have on that. One last one of these is if we look at our author, author has a date of birth which is of type date time. So in C#, we only have this date time structure that we use both for storing dates and times and the combination of the two. But let's be honest, when you have a date of birth, you don't know what time the person was born at typically. You just want the day, the month and the year, no more than that. But by putting a date time in there, that maps onto, in our database, it has this particular date time type, which is storing more information than we need, and therefore is a bit of a waste of space, and can also sometimes cause a bit of confusion if two dates don't match up exactly, not because the dates are different, but because the times are different. So again, we can use this column and data type on there. So all we need to do is on this one, say column, and then type name equals, and if we just go for the SQL Server type of date, then that's something that I'd try to remember to do early on, because once you've got lots of date times in there, it's a bit of an effort to convert them. So do think about that early on, and whenever you've got something that is really just a date, even though it's a date time in C#, you want it as a date in your database. And so we can see now that's just a date and using up less memory. So that's it for our look at the attribute-based way of configuring how our entities map onto our tables. Not been completely comprehensive there, but I've shown the basic ones, and most of the things that you think might be possible are possible. You can look them up and see how to do it. I say most of them, not everything. Next time when we look at the Fluent API, we'll see that actually it is a bit more flexible. There are certain things you can do there that you can't do with attributes. That said, as well as the attributes directly provided by Microsoft and Entity Framework, there are some third-party libraries that provide additional attributes to do this sort of configuration. And what that obviously implies is you could write your own as well. So if you want to do everything through attributes, you can do it, but you might have to write your own. Next time, though, we're going to be looking at the Fluent API for doing exactly the same thing and a little bit more. So if you enjoyed this video, do like it, and if you really enjoyed it, do subscribe so you won't miss the next one on Fluent API.